So we're starting the statistics and probability unit. Chapters 3 and 4. And in a few weeks, we'll take test 2. All right, up there. I guess also before I get into the material, let me just mention, obviously, we took test 1 at the end of last week. Hopefully you did well on that. If you didn't do well, then make sure, next time you look through the homeworks and that kind of stuff. You can, if you want, you can take a look at how well the test matched up with the homeworks, previous homeworks. Usually there is like one homework problem per section, or 1 or 2 homework problems per on the test per section, right? So again, see how that matched up. And in the next unit, this coming unit, it'll be roughly the same thing. Okay. All right, so let's get started. We're going to talk about statistics in this chapter. Statistics in general is the science of collecting, organizing, analyzing, and drawing conclusions from data. So the reason we want to collect, organize, analyze, and draw conclusions is because that gives us really good insight on general trends. So what are general trends in the data? Those types of things. Now, whenever you're talking about statistics and trends in general, we have to understand that trends in general are applied to groups, but not every individual in the group is going to fall into the trend, the general trend. So you could say in general, you have a higher chance of contracting lung cancer if you smoke. That does not mean every individual who smokes is going to get lung cancer, or that no individual who doesn't smoke is going to get lung cancer, right? So again, gives us really good insight in general trends, but oftentimes we have to realize we're talking about the group, not in every single individual in the group. Now, whenever we're dealing with statistics, we're dealing with variables and data. Variables are the characteristics or the traits that individuals can assume. If we're talking about, let's say, people, then variables are things like hair color and height and weight and gender. What individuals assume for their hair color, or what their hair color is, what their height is, what their weight is, what their gender is. The specific values that each of those takes on for any individual are the data. So, about hair color, well, some individual out there may have brown hair. So, brown is the data, or is a piece of data, and hair color is the variable, the characteristics. Everybody understand that? So the characteristics are the variables. The data are the actual values. Height, maybe somebody is 68 inches tall, right? Just for instance. Another distinction we need to make is the population versus the sample. The population is the group that is studied, the overall group that's being studied. The sample is a subset of that population. So a lot of people get this wrong because they think of the word to be studied differently, or they think of that as almost synonymous with experimented on, but that's different than being experimented on, all right? If I am a medical researcher and I'm doing a study on some new cancer treatment, I might have 20 people that I give this new cancer treatment to. Those 20 people are the sample. However, I'm using those 20 people to study a larger population of everyone with cancer. Does that make sense? So you use the sample to study a larger group, and that larger group that you're attempting to study is the population. So studied doesn't mean the same thing as being experimented on. A lot of times the experiment happens on a sample of the population, and you use that to study the bigger group. All right. Now, speaking of samples, there's a lot of different ways to get samples. We're going to look at 4 here. One way to get a sample is to do a random sample. In a random sample, the researcher doesn't know what sample is going to be, what the sample is going to be. All right. Now, there's a couple of different ways we can do that. One way we can do that is by putting everybody's names into a hat and then drawing names. Okay. And that's convenient when your population is fairly small. If my population was everybody in this class, I could put everybody's name in a hat, draw, a few people's names, and then that would be my sample. That'd be a random sample. You could also have a random number generator built into a computer somehow. Our calculators have random numbers generators if you have a TI-84. TI-30 doesn't, but there's random number generators built into calculators now that you can do. And that's basically how polling is done right now. They have a list of people's numbers and they use a computer to randomly generate out a sample. So a random sample is where the researcher doesn't know what's going to be picked. And an example of that is that computer random number generator. All right. Another type of sample is the systemic sample. Root word there is a system. All right. A systemic sample is when, as the researcher, you're going to pick every, I'm going to put kth person. Now, what we mean by kth person is the following. Let's say I wanted to do a poll on what issues were most important to voters in the last election, all right? So what I do is I stand outside of a precinct, and as voters walk out of the precinct, I just ask them the questions. Now, if I want a systemic sample, what I would do is I would ask the first person, and then I would wait 9 people, and then ask the 10th person. And then wait another 9 people and ask the 20th person. Wait another 9 people and ask the 30th person. Does that make sense? So, an example of this would be you pick every 10th person that walks out of a polling precinct. Is that right? Now, maybe this precinct is really busy. If this precinct is really busy, you might not want it to be every 10th person. Maybe you want it to be every 30th person that walks out. Kind of depends on how busy and how many people are going to go to that precinct. Does that make sense? So that's why it's called pick every kth person. Could be every 10th person, could be every 30th, could be every 1,000 if you're really interested in doing that. Another type of sampling technique is called a cluster sample. That's where you pick a group of people all at the same time. So you're picking a group of people roughly all at the same time, or doesn't always have to be people. This would apply to anything. So for example, let's say I want to do the same thing I did here. I want to see what people's biggest issues were that they were voting on. Instead of waiting all day outside of a precinct and picking every 10th person, I'm going to pick the next, let's say 40 people that walk out of the precinct. And those next 40 people are going to be my sample. That makes sense? And then lastly, we have what's known as a convenience sample. All right. Make sure I had the right one there. A convenience sample is you pick a sample because it's easy to get. So an example of that would be like if I made my friends my sample. Let's say I wanted to figure out what are the biggest issues that people are voting on, and I just picked my friends. Another example of a convenient sample is if we put out a survey on the internet and people can choose to respond or not. By the way, when somebody can choose to respond or not, or ignore the survey altogether, that's called a self-selected survey. So you self-select to take the survey. So if you go on to some website, let's just say you go into YouTube, and there's an ad in the upper right corner, and you can click on it, and it can ask you some question about, do you approve of this policy or that policy? That's an internet survey, that's a convenience sample. These convenience samples are not scientific in general. Think about the other example I gave you, picking your friends. If you pick your friends, your friends are not a good representation of society in general. All right. Probably they'll live fairly close to you. They, have similar likes and interests and all that stuff. So your friends are probably not representative of a larger population. Okay. So convenience samples are not scientific. The other ones, so you never really want to do a convenience sample and scientific testing. The other ones are, random sample is perfectly fine. A systemic sample, in the cases which require a systemic sample, is perfectly fine. Cluster sample can be done scientifically. You do have to worry a little bit about the cluster sample. You have to worry a little bit about timing. If I go right now to Meijer and I look at the demographics of people who are shopping at Meijer right now at 10:20 on a Tuesday, they're going to look different on average than the demographics of people who are shopping Friday night at 11 p.m. on Friday night. So if I took a cluster sample right now of people at Meijer, and then I took a cluster sample of people Friday night at Meijer, they might have different responses. They might be two different groups on average demographically. Does that make sense? So be careful about the timing of cluster samples. They can be done, and it's fine to do cluster samples. They are scientific when they're done right, but timing does impact. And there's famous examples of people doing cluster samples and getting things wrong. All right, people did cluster samples at certain precincts. And if you do it at certain times of the day, Republicans are more likely to vote at certain times of the day, whereas Democrats are more likely to vote at other times of the day. So if you do it at one time of the day, you might get a different result than at a different time. Okay. So all of those types of things matter in cluster samples. So those are 4 different sampling techniques that we look at: random, systemic, cluster, convenience. Okay, there are others too, but I don't need to deal with that. Now, the other thing that we're going to look at in this unit, other than statistics, is proportions. So we're going to look at proportions in the next chapter fairly in depth, but I wanted to at least mention them right up front and what a proportion is in case I use that term later. Proportion is just a percentage of the total population. And usually we don't write it as a percentage, but usually we write it as a decimal rather than a percentage. So like 90% is written as 0.90, or 7% is written as 0.07. Okay. And I bring those up right now because obviously there's a lot of polling that's done. And if you watch the news a lot, there'll be a lot of polls that are shown and things like that. But yeah, it is a percentage of the total population, proportion. Okay. Now, when we're dealing with statistics, we're going to be dealing with various types of data. So I'm going to talk about some various types of data that we can see, or that we are going to see statistically. Okay. The first breakdown of different types of data that we're going to see is actually a breakdown of different variables, right? So when we break down data and variables are linked because data are the values that the variables can take on. Does that make sense? So we're going to break down the idea of variables. The first breakdown is between quantitative versus qualitative variables. Variables that are quantitative root word there is quantity. So it's measuring amounts. There's some sort of a numerical measurement. Qualitative variables are variables that measure qualities. Now, officially, quantitative variables are numeric So they're talking about numbers. So the data that they take on are numerical, but also ordering makes sense. Just because something is assigned a number doesn't necessarily mean ordering makes sense. So for instance, if I was doing hair color, I could assign the number 1 to brown hair, the number 2 to blonde hair, the number 3 to red hair, the number 4 to black hair, right? Or I could have mixed up any of those numerical values, right? Red hair could have gotten 1, and black hair could have gotten 2, and brown hair could have gotten 3, and blonde hair could have gotten 4. So the fact that hair color could be assigned values does not make it quantitative. Hair color would be qualitative. Even if I assign it values, the ordering of those values don't make sense. Or are assigned at random. That makes sense. So let me give you a couple of ideas, hopefully to hit this home with examples. All right. So all right, so let's think about some quantitative examples that apply to humans. Well, things we saw earlier were like height, or weight. Those are variables that take on numerical values, and ordering makes sense. It makes sense to say I am 2 inches shorter than my brother. Does that make everybody follow that? So we assign numbers like how many inches tall you are, and it makes sense to order those. You could put people in height-wise, shortest to tallest, or tallest to shortest, whatever ordering you want. Also things like, how many children do I have? So my mom has 3 children, right? That gets a numerical value. And ordering makes sense. It makes sense to say, I have 1 more child than my mom had. Or it makes sense to say I have 2 more children than my brother has. Or something like that. So things like number of children also are quantitative. Now, let's do some qualitative examples. I already mentioned the one earlier of hair color. Hair color, pretty straightforward. It's a color of hair. It's not quantitative because it's not a number value, right? Usually. And we can force a number value onto it, but it doesn't do any good. Another one is something like zip code. Now, zip codes are numerical. In fact, the zip code that we're standing in right now is 48858, right? So even though it is numerical, it is still not quantitative, it's qualitative. Because zip code is just a random assortment of 5 numbers assigned to a location. If I told you my mom's zip code was 10,872 higher than ours, that doesn't tell you anything about where she lives. East of here, west of here, north of here, south of here. Okay. And if tomorrow the zip code that I live in and the zip code that my mom lives in gets swapped, nobody would have had any issue. Well, I mean, people would forget it, but you know what I'm saying? There's no big societal impact. The ordering of those 2 numbers is a completely just random number assigned to a location. That makes sense? Most of the numbers close to 48858 zip codes, most of them are assigned to locations nearby just because that's how it historically happened as people were, assigning zip codes. But there's all kinds of situations in which 2 zip codes that are numerically really far apart are right next to each other because they had to add another zip code in. So they had to put an extra one in a certain location. That makes sense? So zip codes are a good example of qualitative, or zip code is a good example of a qualitative variable that has a numerical value. Okay. Does that make sense? So quantitative versus qualitative. So once we understand the difference between quantitative and qualitative, we're going to look at 4 different categories of data. Now, on the next few slides, these 4 categories I'll list out. So you don't have to, I want to list them out once, but then I'm going to talk about each one individually. All right. So the 4 categories of data are nominal, ordinal, interval, and ratio. And it kind of builds from like hardest to use statistically to easiest to use statistically. I think of like the lowest amount of good properties versus the highest amount of good properties. Okay. So let's start with what would you want in data? Well, one thing, you want your data to have categories. That's what nominal is. Nominal, when you think of this, is categories, but no ordering or direction. So you're going to see a lot of qualitative variables here. Things like hair color or marital status, race. Those things have categories, but there's no order. Right? You wouldn't order hair color or order race or whatever. So there's categories, but no ordering and no direction. So when you talk about, for instance, hair color, we don't think of one hair color being less than another hair color. Or marital status. One marital status we don't think of as less than another. One race less than another. We don't think that way, right? So there's categories, but no direction, no ordering. That's nominal. And the root word there, nominal, it means there's a name, right? Nominal means there's a name, but nothing else. So we've named a bunch of categories, but nothing else. Then we move on to ordinal. Ordinal means there is some order. So there are ordered categories, but there's no measurement between categories. And the best case here is things like rankings, the best example. Things like rankings. If I ranked best to worst musicians, okay. So this is my own ranking of best to worst musicians. I can order them, you know, top 10. But maybe my number one musician is way, way better than my number two musician. Or it could be that my number one musician is really, really close to my number two musician. All right, and it was a hard decision. Does that make sense? So just by looking at a ranking, you don't know how far apart I think or we rank those individuals on the list, those musicians. The same thing with NFL playoffs. In the NFL playoffs, there's like a ranking system. The top seed, then the second seed, and then the third seed, fourth seed. But between the top two seeds, there might be a huge gap in how many games they won. You know, the top seed might have won 15 games, or the second seed might have won 10 games. Or it could be that they both won 14 games, right? And that criteria is broken through some other means. I don't know what the other means are, but rankings in NFL playoffs are that way too. Letter grades, to some extent, are also that way if I don't know the percentage behind the letter grade. Okay? If I say I earned an A in this class and my sister earned a B in this class, well, my A might have been close to 100% and her B might have been close to, 83%. Or it might be my A was like 93 and her B was like 87. That makes sense? So if you just see letter grades, there's an order. A is better than B, is better than C, is better than D, is better than F. But we don't know how the measurement between each letter grade is. Sometimes it can be a lot, sometimes it can be a little. So by the way, if you think about this, nominal is almost always exclusively qualitative variables. Things like letter grades and rankings, that's ordinal. You can make a case for that being a little bit, I guess it depends on on the context, that's quantitative because there is a numerical. So if it has a numerical ranking, then you could claim that that's quantitative. But where we really get into the quantitative realm is in the interval. Interval is ordered data with measurements, but we don't have a true zero. A good example of this is birth year. Now you might think, well, isn't birth year the year zero, right? Well, not exactly. I could ask for Julius Caesar's birth year. It'd be in the BCs. BC, I'm guessing 100 BC, maybe? Something there. I forget how old he was when he went into Gaul, but that was campaign. That campaign was like in the 52, 48 BCs. So that's when he was most famous, in the 50 BCs, but he was obviously born before then. So birth year would be a good example. All right. Think of comparing my birth year versus Julius Caesar's birth year. You know, they're almost 2,000 years apart. So we could measure the distance between my birth year and Julius Caesar's birth year. It's ordered because I could say he was born before me, but there's no true zero. There's no zero birth year. Okay. Temperature in Fahrenheit is another good one, because you can get the negatives, right? So we measure temperature, same thing with Celsius. Celsius can go negative too, but if I'm talking about temperature in Fahrenheit or temperature in anything, there's no true zero. All right, IQ is that way as well. That's not as important, but it's ordered. We can measure between, so I can say at 10:45 today, it was 3 degrees hotter than 10:45 2 days ago, right? So I can measure between two different points in time, temperature, but no true zero. And then the thing with all of the data types, with all of the nice properties, those are called ratio, right? Ratio data is ordered. There's measurements between, and we have a true zero. Things like height and weight having true zero. Age has a true zero. Can't be negative years old. You can't be negative weight. Can't be negative height. That makes sense? So you always start at zero with your measurements. So no individual is going to be 0 inches tall, but we understand that height has a starting point, a 0 on the scale. Weight has a 0 on the scale. All right. Has a true zero. Age has a 0. Time of your birth, right? So notice again, all of these things, in some ways, the birth year, the temperature, those could go into the negatives. That makes sense? So that's an interval versus ratio. can we go into the negatives? Ratio has a true zero, so you're not really going into the negatives there. Does that make sense? And in general, ratio is the nicest thing to deal with. All of my examples for the quantitative ideas, the height, weight, and number of children, were all ratio. If you think about number of children, it's order. Measurements are between. You could say, again, I have two more children than my brother. And there's a true zero. Makes sense to have 0 children. You can't have negative children. So, ratio there. Now, the reason I bring up these different measurements, the nominal, ordinal, interval, and ratio types of data, is because which one we use actually affects how we treat the statistics at high levels. We're not going to get into different types of testing in this class, but it turns out if you're doing a research project and you have nominal data, then you have to use a different test than if you have ratio type data. So once you get into doing things like hypothesis testing, the type of test you use differs based on the types of variables and data that you have. All right. So that's why we know it. And I'm not going to get into the tests because there's a bunch of different tests. Okay. Does that make sense? Okay, so we've talked about statistics, what statistics are, how to measure, how to treat samples. Now let's actually do some calculations. So collecting, organizing, analyzing, drawing conclusions. One of the ways we can organize our data is to find where the center of our data is. Now, that's essentially what central tendency does. Central tendencies are one of the most often cited form of statistics. And essentially what central tendencies are looking for is where the center of the group is, or what is the tendency of the center of the group? Where does the center tends to be? All right, I think of it that way. So it's looking for the center of the group. And it turns out there's a lot of different ways to find a center of a group. Just like there's a lot of different ways to find the center of a triangle. You guys probably don't know this, but when you find the center of a triangle, you can do so in a lot of different ways. One way, I'll try to draw on this. One way is to draw perpendicular lines in the middle of each of these and see where they meet up. right? They should meet up at one point, perpendicular lines in the middle. Another way to find the center of a triangle is to draw a circle that is around and touches all 3 points, and then find the center of that circle. Okay. Another way is to draw a circle inside, and draw that very well, and draw the center of that circle. And it turns out these points are often different. Okay, I won't get into the details, but a lot of times those points are different. And so just like there's a number of different ways to find a center for a triangle, there are a number of different ways to find the center of a data set. Now, the more common ways are what we're going to look at here. The 3 most common ways of finding the center of a data set. The first is the mean. The mean is the average. And in this class, we use the average and the word the mean interchangeably. So the mean is the average. The median is the middle number. And by middle number, we mean numerically. If we ordered all of our numbers in our set, the median would be the middle. And the mode is the number that is seen most often in our set. So the mean is the average. I'm gonna write a short mathematical description. I'm gonna write this symbol, which means add up. This is a capital sigma. Add up all of the values in the set, which I'm just gonna call x's, x sub i's. So we add up all of the values in the set and divide by the size of the set. So we add up all of the values in the set and then divide by the size of the set. Does that make sense? And that's the shorthand mathematical version for telling people that. Add up all the values in the set, divide by the size of the set. The median is the middle number. I'm just going to write the word numerically. So it's the one that's, when you order numerically, it's the middle one. And just as an example, if I have 3 numbers, 4, 7, and 1, which one is the middle number numerically? Well, the middle number numerically is the 4. Okay with that? So 4 is the middle, numerically. So 4 would be the median in that case. By the way, if I wanted to find the average, I would add those three numbers up and then divide by 3. Right? And the mode is the most often. So in the set, it's the one that's seen most often. And just as a note, if everything happens exactly once in a set, we say the set has no mode. So if everything occurs once, it has no mode. And if there's like a tie for most often, then we just say all of the numbers which tie are modes. So we can have 2 numbers that are most often. Does that make sense? So if I have a set like 1, 1, 1, 3, 8, 9, 10, 12, 12, 12. The numbers that occur most often are 1s and 12s, right? And so if that were the case, we'd have 2 modes, a 1 and a 12. All right. The fancy word for that is that our set is bimodal. Bi means 2, prefix 2, so bi 2 modes. And if you have a tie, like a 3-way tie at the top, then it'd be trimodal. You'd list all 3 numbers. Then if you have a tie, you list them both. And again, the only exception to that is if there's one. If everything is listed once, or every number here is listed the same amount of times, we say there's no mode. So if I did this, and that was my set, I'd say that set has no mode. Everything is listed one time. So there you go, mean, median, mode. So I want you to take a look at this set. Let's say there's some small business out there with 5 employees. I want you to find the mean salary, the median salary, and the mode salary of these 5 individuals. Now, obviously, we're going to have to use our calculators here to get that. So what I did to find the average, I took the 38,500, added the 35,000, added the 45,000, added the 237,000, and added the 62,000. All up. And because there were 5 numbers in the data set, after I added those things up, I divided by 5. Now, make sure that you add up the numbers all together before you divide. Okay? So make sure you add up all the numbers before you divide. But when all said and done, we end up with 83,500 as the mean. By the way, because these salaries were in dollars, technically our average is going to be $83,500. Is that okay? I bet get 83,500 if they did that. Now the median, this data set wasn't listed in order from least to greatest. Actually, the 35,000 is the smallest. Next smallest is 38,500. Next smallest is 45,000. Next smallest is 62. But there are 5, right? There are 5 numbers. And it turns out the middle one numerically is 45,000. Once again, technically it's $45,000 because we're listed here in dollars. Everything is listed in dollars. And then lastly, we look at our numbers and we're looking for repeats. And it turns out there are none. There are no numbers that repeat. And therefore, for our mode, we would say that there is no mode. That work? Pretty straightforward. Now, here's something that we'll talk about later, but I'm going to draw your attention to it right now. Okay. I want you to notice that there's a big difference between this number and this number. Right? Those are 2 different numbers, the 45,000 versus the 83,500. If I told you at this company, the mean salary is 83,500, you come away with a different impression than if somebody else would have said the median salary is 45,000. Okay. Again, those 2 numbers are very different. And sometimes our measures of central tendencies can give us very different numbers for those different measures of central tendency. Does that make sense? So that's one thing to watch out for. If somebody is telling you a central tendency for the group, you could always ask, well, why did they choose this central tendency as opposed to this other central tendency? Sometimes it's because if I want to be a person which makes this company out that they're paying people a very high salary, then I'm going to use the average. If I'm somebody who wants to draw a narrative that this company is paying low salaries, I might use the median. Does that make sense? So it kind of depends on what story I want to tell. I want you to do this one on your own. Find the central tendencies of these 4 individuals' weights. All right. Central tendencies for sets this size don't take real long to calculate. Okay. So if we're gonna do a central tendency here, we take 140 plus, or do an average, do a mean here. We take 140 plus 140 plus 170 plus 210. And then after I add those up, I divide by 4. I get 165 there. By the way, since these were all weights in pounds, 165 would have also been in pounds. Okay. The median. Now this one is interesting because when you order the numbers numerically, because there's an even amount of numbers in our set, I don't have a true middle number. In my last example, there were 5 numbers in our set. So third listed was the true middle, right? Here, I don't have a true middle number. And so what I do is I say, well, actually the middle number I'm going to call halfway between 140 and 170. I take my 2 middle numbers and I go halfway between that. Everybody all right with that? And in the mode, that's just the number that appeared most often, which in our case is 140. Again, if I wanted to paint a story about the 4 individuals here being heavier, I would use the average. If I wanted to paint a story about these 4 individuals being lighter, I'd probably use the mode. Okay. When telling people about this data set. Let's do one more example. Here we have a data set of 6 different buildings. In fact, these are the 6 tallest buildings in the world as of, I believe, 2 years ago. So as of 2 years ago, these were the 6 tallest buildings in the world. There might be a different one now with this. gotten to the list, but I want you to find the central tendencies here. Height is measured in feet. These are also in numerical order. So you don't have to reorganize too much. Burj Khalifa, that's, let's say in Dubai or UAE, something like that. All those other ones, I believe, are in East Asia somewhere. Okay. All right. So, our average, there are 6 numbers. So I'm going to add those numbers up. Divide that, sum by 6, and I got 2,100. This was all measured in feet, I believe. If I'm not mistaken. All of the data were measured in feet. The median, well, the 2 middle numbers were the 2060 and the 1972. So my 2 middle numbers, I'm going to add up and then divide by 2 to get halfway in between. And when I got that, I got 2016. And then for this data set, no number occurred more than once. So we say there's no mode for this data set. In Moodle, I forget what it asks you to write. It might ask you to write none, N-O-N-E, if that happens, or something of that nature. Okay. Again, median would also be measured in feet. Now, as you can see, in this mean and median, there's not that much of a difference. There's not that much of a big difference between the mean and median of this set as there was between that salary of individuals set that we looked at to begin with. So some data sets, the mean, median, mode, are all way apart from each other. And sometimes the mean, median, mode can all be like right precisely in the middle. When I was drawing those triangles earlier, I was careful not to draw an equilateral triangle. because an equilateral triangle, all the different centers are in the exact same spot. Okay. So. Those types of things. All right, any questions about this concept? Calculating mean, median, mode. Next time, what we're going to do is we're going to say, well, here's the data set. What value do I need to plug in to get a certain average? What value do I need to plug in to get a certain median? What value do I need to plug in to get a certain mode? And so we'll look at that type of thing next class period. All right. If you want to start on homework, you can. The homeworks, there's a couple of homeworks due, I believe. But you have everything you need to, do 3031. And then you can start on 32. The calculation part, you know how to do. The other part we'll do next time along with spread measures. Okay. All right. Well, what I got for today, I will see you all next time.